with its crushing atmosphere 90 times as thick as ours, and temperatures reaching an unimaginable 462 degrees Celsius, Venus is the last place in the solar system you would expect life to survive. But in the past things looked very different, and the planet might have provided a comfortable place for life, for up to 2 billion years of its early history, according to a new study. Computer simulations by NASA scientists have shown the now uninhabitable second rock from the Sun might have had a shallow liquid water ocean and habitable surface temperatures. Scientists at NASA's Goddard Institute for Space Studies in New York used a model similar to the type used to predict future climate change on Earth to look into Venus' past. Many of the same tools we use to model climate change on Earth can be adapted to study climates on other planets, both past and present, said Dr. Michael Way, a researcher at JIS and the paper's lead author. These results show ancient Venus may have been a very different place than it is today. Scientists have long thought Venus formed out of ingredients similar to Earth's, but followed a different evolutionary path. In a study published in June, scientists at Rice University said minor evolutionary changes could have altered the fates of both Earth and Venus, creating a situation in which life could exist on a lush, green Venus and Earth would be a dead planet. The researchers said minor evolutionary changes could have altered the fates of both Earth and Venus, and hoped to soon be able to model them. Measurements by NASA's Pioneer mission to Venus in the 1980s first suggested Venus originally may have had an ocean. But since Venus is closer to the Sun than Earth and receives far more sunlight, the planet's early ocean evaporated. Without water left on the surface, carbon dioxide built up in the atmosphere, leading to a runaway greenhouse effect. Dr. Way and his JIS colleagues simulated conditions of a hypothetical early Venus with an atmosphere similar to Earth's, a day as long as Venus' current day, and a shallow ocean consistent with early data from the Pioneer spacecraft. The study also factored in an ancient Sun that was up to 30% dimmer. Even so, ancient Venus still received about 40% more sunlight than Earth does today. In the JIS model's simulation, Venus' slow spin exposes its dayside to the Sun for almost 2 months at a time, co-author and fellow JIS scientist Anthony Delgenia said. This warms the surface and produces rain that creates a thick layer of clouds, which acts like an umbrella to shield the surface from much of the solar heating. The result is mean climate temperatures that are actually a few degrees cooler than Earth's today.